So we have been discussing about photoinduced electron transfer reaction. We have already looked a few examples, and here are a few examples of photoinduced electron transfer using perchlorate salts. So photoinduced electron transfer, photoinduced electron for reactions using chlorate, ammonium chlorates, ammonium salts, ammonium chlorate salt as an electron acceptor. So using with alkene, and alkene being electron donor. So a lot of examples have been reported using this ammonium chlorate salts, and these after generation of radical anion and radical cation species, it led to the formation of very important, synthetically important compound. So if we have is salt, ammonium salt like this is C plus, you have R1 and R2 and R2 ClO4 minus, ClO4 minus. So when this is an alkene, a tri-substituted alkene which is acting as a, so this is an acceptor, this is acting as an electron acceptor, this is acting as electron donor. In the presence of light, there is an electron transfer from alkene to this ammonium salt, giving rise to a cation here, because radical anion, this positive charge gets compensated to give a radical species here. So you, after electron transfer, we get a radical, a carbon center radical, because anion is getting compensated with the positive charge, plus the radical cation as the radical cation is an alkene, the electron donor. So we have a system like this, and then this is single electron transfer. Electron transfer gives rise to radical and radical cation species, and then this gets back to single electron transfer reaction. So these reactions have been well established. The ammonium salts, chlorate salts, acts as a very good electron acceptor. The alkene being electron donor, generating radical, ammonium radical, carbon center radical after accepting electron, and radical cation, alkene being the radical, and this comes back, and so this is intermolecular electron transfer reaction, intermolecular electron transfer reaction. Intramolecular electron transfer reactions have also been reported, being ammonium salts being the part, the electron donor, the both electron acceptor and donor being in the same molecule, and the electron transfer from this has also been reported. So if we have a system like this one, this is of course ammonium salt, you have an alkene R, and of course this is a part of the some system. So here, in the presence of light, undergoes single electron transfer from this is this part being electron donor, this part being electron donor acceptor. So there is an electron transfer from alkene to this, generating a radical species, carbon central radical, a carbon central radical, as well as, and then this being the radical cation. So you can see, and then this comes back to back single electron transfer. So these electron transfer reactions from alkene to ammonium salts have been well established, and this has been exploited for a large number of reactions, and many studies have been done with the 5-membered nitrogen containing ammonium salt. So if we have a system like this, you have a phenyl group here. This is, of course, this is H with the positive charge, ClO4 minus, plus this being the alkene, being the electron donor, CH3 in the presence of light undergoes single electron transfer, giving a carbon central radical, a radical here, a pH, plus of course we have a CH3 radical cation. Then there is a coupling of the radical coupling, giving rise to and then the quenching with methanol. So quenching with methanol gives rise to a product. Here if we have a of course generate a phenyl here, it can add radical coupling, the CH, and then this is positive charge, and then this can of course can abstract a proton, can quench with methanol, CH3OH, to give phenyl OCH3. So you can see a very the alkene added product from to this ammonium salts have been reported through the single electron transfer reaction, first generating a carbon center radical, then radical coupling to this, the adding to this radical, and then a positive charge. So if we can write like this. You have a radical here, a positive charge here, CH3. So this is going to add to this to give this, and then the positive charge, and then not only this, the reaction of this ammonium salt with cyclohexene has also been cyclohexene has also been reported. And if we have a system, the same ammonium salts, you have a plus ClO4 minus, this with cyclohexene as an electron donor can undergo as usual single electron transfer to generate a carbon central radical, a pH here, and then this of course plus radical cation can add to the radical cation, giving rise to a can add to this species, giving rise to a product like this. And then a positive charge here, which is trapped by methanol, pH here, trapped by CH3OH to give methanol added. So this is a very is a highly studied reaction involving the electron transfer with the variety of alkene OCH3, variety of alkene. Earlier one is a dimethyl ethylene. This is a cyclohexene can add first electron transfer to radical cation, addition, radical coupling to give carbon center, a quenching of the carbocation by methanol to give methanol added product. Not only this, the reaction of this has been has also been it is possible that it may also undergo minus H plus to give an alkene here. So another product is also possible with the these products have also been reported. As far as the reaction of the same ammonium salt with the the butadiene has also been reported. If you have same electron acceptor is ammonium salt ClO4 minus plus butadiene, giving rise to, in the presence of light, single electron transfer leading to a carbon central radical plus a butadiene radical cation. This lead to maybe radical coupling. So a number of products are expected here. This may add to, say for example, if we write this to say radical cation, a double bond, then we expect a double bond here, a positive charge here, and then the trapping with methanol give rise to a product like this. So we can see these reactions are highly OCH3 very nicely reacts as a electron donor. So electron acceptors. Is also possible that it may add to other carbon central radical, and then so on and so. So there are many products possible adding to the other radical. For example, we have a pH here, might add to a positive charge here, and then a double bond, and this positive charge is OCH3. So these products there is also possibility of the addition of 4-membered ring where we can end up with this positive charge. So see 1 2 3 4 the say for example, if we have a system like this, a radical here, this radical might add to this this positive charge. So plus, so we have a positive charge here, and then you have a double bond, and then the lone pair of this might attack here to give a 4-membered ring. So the reaction of a pH here, and then 4-membered ring. So we can see a large number of products have been expected here. You can see here the butadiene, which is the donor here. On electron transfer reaction, radical generated and radical cation may add in a different fashion to give a very interesting 4-membered ring, which is synthetically important and plays an important role in this. Not only this, the reaction with the other derivatives have also been reported. For example, if we have a system pH plus charge ClO4 minus reacting with is an ester, ene ester CO2CH3 giving rise to a carbon center radical after the electron transfer, pH, and then plus this radical may lead, of course there is a cation here, radical cation. This may add in this fashion to give this COCH3 to give a product like this, pH, a positive charge here, CO2CH3. And now this CO2CH3 can be trapped by methanol, CH3OH, to give methanol added product, pH, OCH3, CO2CH3. It is also quite possible that this lone pair may also, if we write like this, say for example this one, this ester part may also be involved in the cyclization. For example, this N, pH, your methyl group, C double bond O, OCH3, the lone pair. I'll just write in a better way. So I'm writing this product once again. So we C double bond, this one, this is pH, this is C double, 2 methyl groups, this is methyl, this is OCH3, C double bond O, OCH3, and this is lone pair of electron might attack here to give a cyclized product. So we end up with a 1, 2, 3, 4, 5 membered ring with the carbonyl. So it goes like O minus, OCH3, you have a 2 methyl group, you have a methoxy group here, OCH3. This might go and then as a methanol loss, OCH3, CH3. So we are going to get a product like a cyclized product. So this is really a very interesting reaction in the sense that 2 methyl group OCH3. So starting with this 5 member nitrogen ammonium chlorate salts reacting with this alkene, single electron transfer, giving rise to radical, carbon center radical, a radical cation. This radical might add to give this alkene added carbocation trapped by methanol, giving rise to this product. And then there is a possibility of involvement of the lone pair of nitrogen to this ester may cyclize to give a bicyclic ring system, a 5-5 ring system. Very interesting from synthetical point of view. And the other reactions have also been shown, which are very important from the synthetic point of view. For example, if we have a system like this, it has been found that intramolecular. So this is we have a donor acceptor. In the same system we have a ammonium salts, ammonium chlorate salt, which is acting as an this is acting as an acceptor. This is a alkene which is acting as a donor in the presence of light, single electron transfer reaction, giving transfer an electron from alkene to this to give a carbon center radical in the In the ring system, we have a nitrogen here, this one, and then we generate radical cation. This is a carbon center radical. Now this might has been reported to under radical coupling to give a cyclized product. So you can see from a bicyclic system we end up with a 1 2 3 4 5 1 2 3 4 5 membered ring. This 2 as a positive charge, right, and then this will be trapped by methanol, positive charge, OH, to give C double bond O, nitrogen, OCH3. So you can see the intramolecular photoinduced electron transfer reaction giving rise to a tricyclic ring system. The five member ring is, of course, is a 6 member. Sorry, 6 member ring. So this is really a very interesting reaction, and there is a possibility of this not only this coupling not only gives the only cyclized product, the other cleavage products have also been reported. So for example, this if we can, I can write this, there is also possibility that this radical may go cleavage to give C this is one fragment, and then the side chain is removed. So here this is a radical here, radical cation, and then this of course not here. So when this goes as a positive charge, and then this is again trapped by methanol to give two products. Either you get a OCH3 or we get a methanol here, the OCH3 plus methanol here. So let's write in a better way. So for example, you have a double bond, positive charge, you get this. If methanol is adding to this, there is a possibility to this double bond here. So you have the methanol OCH3 as methanol can add to this product. So the two pathways are open for this intramolecular single electron transfer reaction with carbon center radical and radical cation. This radical may undergo radical coupling, to give a cyclized product, or it may undergo fragmentation to give this as a both the side chain as a separate part and the other as a separate part. So this is another reaction of using five membered ammonium salts have also been reported, where we have a ClO4 minus plus cyclopropyl alkene as an electron acceptor, this be acting as electron donor. In the presence of light, single electron transfer to generate a carbon center radical plus this is a acting radical cation, and this radical cation might add to radical coupling, giving rise to a product like this pH. A positive charge might trap with methanol, giving rise to a of course we have a substituent here, pH OCH3. So we can see a large number of reactions involving photoinduced electron transfer reactions, where the ammonium salts are acting as an electron acceptor, alkene being an electron donor in the presence of light, giving rise to carbon center radical. A radical can has been well established because it can further go back to a starting material on back electron transfer. Intramolecular electron transfer reactions has also been reported, and the use of these electron transfer reactions to give to synthesize synthetically important compound, addition of alkene, addition of cyclohexene, addition of addition of butadiene to this via addition of an ester to via single electron transfer reaction. Even the intramolecular cyclization giving rise to a three-membered tricyclic system has been constructed for this. So these reactions, photoinduced electron transfer reactions, have been exploited for synthesizing synthetically important organic compound, which is not possible through any other simple catalytic method. So these reactions are highly useful and to give the very interesting symptom. Thank you very much.